Hello guys, I'm Varun and today I'll be speaking on the topic the scheduling algorithm. I'll be covering the first come first serve algorithm in this particular video. So we'll start with some basic definitions about the hard drive. So this is the basic structure of a hard drive. Like a hard drive it consists of a stack of multiple platters stacked on top of each other. So like you can see, each platter contains two surfaces. One is the top and one is the bottom surface, which is not visible in this particular image. So each platter can be divided into thousands of tightly packed concentric circles known as tracks. So as you can see that this is a track, and there are thousands of such tracks in one platter on the top surface and also on the bottom surface. And each track can be further subdivided into sectors, multiple sectors, and this is the particular area where the data is stored. So if we move on to the definition of the cylinder, let me change the color. Like, what is a cylinder? A cylinder is any set of all tracks of equal diameter in a hard disk. So let us consider that the diameter of these particular tracks are x each. So the set of all the tracks with the diameter x will form one cylinder. So moving on to the read-write head. What is a read-write head? So a magnetic read-write head is used to manipulate the bits of magnetic pulses in order to read or write from the hard disk. So there are usually two read-write heads on each platter, one on the top and one on the bottom, and these are mounted on head sliders suspended from the head arms. So these are the head sliders and this is the head arm. So the head sliders are basically used to move the heads back or forth in order to reach a particular track or a sector, and this all is placed around a spindle which is used to rotate the hard drive. So moving on, why do we need disk scheduling algorithms? First of all, since seek time is very important for an operating system, and since all device requests are linked to queues, the seek time is increased, which causes the system to slow down. So disk scheduling algorithms are used to reduce the total seek time of any request. So moving on, there are various kinds of disk scheduling algorithms, and we'll be covering the first come first served algorithm in this particular video. But there are also the shortest seek time first, elevator or scan, circular scan, look or see look, that is circular look. So moving on to our example, like we have 200 tracks. We have a disk with 200 tracks labeled from 0 to 199, and there is a request queue which contains the track numbers in the following order: 82, 170, 43, 140, 24, 69, 190 respectively. So we are also given the current position of our read-write head, that is 50. This is the starting position for the question. So we have to calculate the total number of track movements of the head. So I have made the particular sequence first hand. So right now we are on the 50th track, that is the starting position, and from the 50th we have to go to the 82nd track. So we'll go to 82. From the 82nd we have to go to the 170th track. So we'll go from here till here. Then from 170 we have to go to 43. Then from 43 to 140. Then from 140 to 24. Then from 24 to 16. And then finally from 16 to 190. So this is the path that our read-write heads would follow for the first come first serve sequence. So if we want to calculate the total seek time for this particular question, we can do it as the following. Like first we are on 50, now we are going to 82. So we'll write 82 minus 50 plus, we are going from 82 to 170, so 170 minus 82 plus, then we are going from 170 to 43, but the seek time cannot be negative, so we are just going to write it like 170 minus 43. Then we are going from 43 to 140, so 140 minus 43. Then from 140 to 24, so 140 minus 24. Then from 24 to 16, and then finally from 16 to 190. So this will give us the answer 642. So this was a long way. There is one shortcut too. Like consider that we are going from 50 to 170 in a straight line, this particular line. So we can directly write 170 minus 50 instead of this thing. Okay, so plus, we're going straight from here till here, so 170 minus 43 will be the same, plus this thing. Then we are going from 43 to 140 directly, so this will also be the same. Then we are going from 170 to 16 directly, so we'll write 140, 140 minus 16. So we'll just write it instead of this. And then we are going to 190 from 16, so this will be the same, and this will still give the same answer, just that the calculations will become a tiny bit less. So the answer will still be 642. So this was the first come first serve algorithm. So what are the benefits? So first of all, there is no starvation, since all the requests get or processed in an order, like first it was 82, then 170, then 43, so there will be no starvation. And what is starvation? It is the condition where a particular process does not get any resources for getting executed, then it is starved. But nothing will happen, but no such thing will happen here, since they are getting executed in a particular sequence. But there is a con, that is it will have a performance hit. Like you can see that the zigzag motion is too much, so it will take more time than the other scheduling algorithms. So this is the con of the first come first serve algorithm. So that's it for the video, and thank you for watching.